This is the second video of part 2 of factoring trinomials, and in this video we're going to look at factoring trinomials of the form ax squared plus bx plus c when a does not equal 1, or the leading coefficient is not 1. Okay, so let's look at the steps of how to factor over the integers when you have a trinomial and the leading coefficient is not equal to 1. First, you want to factor out a greatest common factor if possible. So that is anything that all of the terms are divisible by. Step 2 is to find two numbers that multiply to a times c. Whatever a times c is equal to, you want to find two integers that multiply to that number and also add to the middle integer b. So we'll be having to identify a and b and c out of our trinomials. Step 3 is to rewrite the trinomial so that there are four terms. The middle term becomes the sum of two x terms with coefficients that are the two integers we found in step 2. The first term and the third term from our original trinomial stay as the first and last term in our new polynomial. And then, once we have four terms, we do step 4, we factor by grouping, just like we did in lesson 5.2, and also in the previous tutorial video. Let's look at an example. We have a trinomial 3x squared plus 8x plus 4. First, we look if there's a greatest common factor we can divide out of every term. None of the terms' coefficients are divisible by a number, 3 or 2 or 4 or anything, and there's no x common factor either. So then we move on to step 2 and we look for two numbers that multiply to a times c and add to the middle integer b. Well, we have to identify a and b and c first. So a is going to be equal to 3, it's the coefficient of x squared. B is equal to 8, the coefficient of the x term, and c is equal to the constant, which is 4. So we need two numbers that multiply to whatever a times c is. So 3 times 4 is 12. We need factors of 12 that also add to 8. So factors of 12 could be 1 and 12, but they add to 13. Let's look at 2 and 6. That looks good. 2 plus 6 equals 8. So 2 and 6, those are the factors that we want to use. So we go back up to our trinomial and we rewrite it. 3x squared stays the same, but we replace the middle term, bx, or 8x, with two x terms with the coefficients of 2 and 6. So it doesn't matter which order. So you can write plus 2x plus 6x plus 4. And again, you could write plus 6x plus 2x instead, like switch the order around. Now we go ahead and factor by grouping just as we did before. So make a group out of the first two terms and the last two terms. The first two terms share a common factor of just x, so we'll divide them by x, and we get x bracket 3x plus 2 left over. Our second group has a common factor of 2. So we'll factor out a 2 out of those two terms, and we'll write that plus 2 there. And in brackets we have the leftovers. 6x divided by 2 is 3x, and 4 divided by 2 is positive 2. This is good. What's in our brackets is the same, so we're going to divide that out as a common factor. 3x plus 2 is a common factor of this new polynomial that we have. And our final answer will be that common factor, 3x plus 2, and whatever's left over after we divided it out, so x and plus 2. Those are from here and here, those are what's left over, because the 3x plus 2's divide out to 1. So we're left with the x and the 2 left over. And therefore our factored our factors of 3x squared plus 8x plus 4 are 3x plus 2 and x plus 2. Alright, let's continue on with some examples of factoring trinomials with an a value that is not 1. So we're looking here at example 2, 6x squared minus 5xy plus y squared. And we look at, the first thing is there any greatest common factor that we can divide out of every term? We're looking at, 6, -5, and a 1, nothing in common, x squared, xy, y squared, no variable shared amongst all three terms. So there's no greatest common factor. So now we're going to look for two numbers that multiply to whatever a times c is. Well, a is 6, so 6, and c is 1. 6 times 1 is still 6. So we need factors of 6 that add to -5. Here we have a list of the factors. I have 1 and 6, but they add to +7. So then let's look at, because we need an addition, or the two integers to add to a negative number, let's look at two negative factors. So -1 times -6 equals +6, but it adds up to -7. So we're closer, but still not the right integers. So then we look at -2 and -3 as factors of 6. -2 plus -3 equals -5. So these are the factors that we want to use. So let's go up and rewrite our trinomial. 6x squared minus 2xy minus 3xy plus y squared. So we just replaced the middle term with the two integers, and the variables are still the same as the middle term in the original question. Now we're going to factor this polynomial by grouping. So we make a group out of the first two terms and the last two terms. Make sure the negative in the second term stays in the brackets. Common factor out of the first two terms would be 2x. They're both divisible by 2x. That leaves us with 2x out front, and then in brackets the leftovers. 6x squared divided by 2x is 3x, and -2xy divided by 2x is just -y. The second group here has a common factor of y. So I'm going to go ahead and divide y out of that, and write plus y in my next step, with brackets. -3xy divided by y is actually -3x. But we have to stop for a second here because we have a negative that we don't want. We want this term to be positive, like in the first brackets. We want our brackets to be the same. So we're going to go back and we're going to change what we're dividing by to a -y. And then that changes this plus y is going to change to a -y. Alright, so, and then that changes to plus 3x, and then positive y squared divided by -y is going to equal -y. Alright, so divide out your common factor of 3x minus y from each of these two terms. 3x minus y is one of your common factors, and your other factor is what's left after you divided by 3x minus y, so you get 2x minus y as your second factor. And that is the factors of 6x squared minus 5xy plus y squared. Okay, example 3, we have 3x squared plus 2x plus 4. So we need two integers that multiply to 3 times 4, which is 12, and adds to +2. So we look at factors of 12. We have 1 and 12, but that adds to 13. We have 2 and 6, which adds to 8. 3 and 4 adds to 7. Even if we try negative factors of 12, I don't think we're going to find a sum that equals 2. But that's all the factors of 12. Because there's no two integers that have a product of 12 and a sum of 2, the polynomial 3x squared plus 2x plus 4 is not factorable. Here is one last example of factoring trinomials. 24x squared minus 30x minus 9. Notice that all of these terms have a greatest common factor that we can take out right off the bat. Every term is divisible by 3 at the most. That's the greatest common factor. Once we divide 3 out, we have to write the 3 out front of brackets so that it is included as a factor. And then we're left with 8x squared minus 10x minus 3 inside the brackets. We are going to factor this in trinomial that's inside the brackets the same way we've been doing on the other slides. So we need two numbers that multiply to 8 times 3, which is 24. And also those two integers have to add to negative 10. Oh, sorry, we have to multiply to 8 times negative 3, which gives us negative 24. Once we have identified those two factors, we can factor by grouping. So factors of 24, negative 24 could be negative 24 and positive 1. Negative 24 plus 1 equals negative 23, so not the sum we're looking for. Now let's look at negative 12 and positive 2. Negative 12 times 2 is negative 24. Negative 12 plus 2 is negative 10. So those are the factors we want. So let's rewrite. Make sure you leave the 3 out front. Times 8x squared minus 12x plus 2x minus 3. Okay, and within that 4-term polynomial, we're going to factor by grouping. So make 2 groups in the front, 2 groups at the back. The first group has a common factor of 4x. So we're going to divide every term by 4x, and that will leave a 4x up front. The last term, 2x minus 3, actually has no greatest common factor, so we're going to still divide it by 1. So here we go. We've got 3 up front still. Then we're going to have 4x, because that was the greatest common factor we just took out. Bracket, leftovers. 8x squared divided by 4x is 2x, and minus 12x divided by 4x is minus 3. Okay, we divided out a plus 1 from the second group, so we write plus 1, and then of course that doesn't change anything when you divide by plus 1, so we still have 2x minus 3. Our 2x minus 3 is now a common factor within our brackets here, so we're going to divide by 2x minus 3. Our final factors are the 3 that we originally divided out, the 2x minus 3 that we now just found as a common factor, so they can cancel out, and our other factor is the leftovers after we cancel out or divide out the 2x minus 3, so we get 4x plus 1. And that's your factors of this example.